Good evening, one and all. On behalf of Endev Series 1 webinar team management, myself, Dr. Pompi Ghosh, welcome all of you in this auspicious evening. This is our 8th webinar under Environment and Development Series 1 webinars. Today's topic is something different, and it is a bottom-up approach for public health development utilizing artificial intelligence and BSM coding. Today's resource person is Vishnu Goswami, Senior Research Scholar, Department of Zoology, the University of Burdwan, West Bengal. So welcome our resource person, Vishnu Goswami. Please, sir, start your presentation.
Thank you very much for the lovely introduction. I'm very delighted to have all of you here. And so let's not waste time and let me start sharing my screen. Is my slide visible? Can anyone confirm?
Yes, visible.
Okay, thank you. So today our topic is a bottom-up approach for public health development utilizing artificial intelligence and BSM coding. So first we have to understand what is artificial intelligence. So it is a term that gets thrown around a lot, and some people wonder if it is something too complicated. And people also ask, how can I utilize artificial intelligence in my day-to-day life or my professional life? So they need the answers. So according to IBM, that the International Business Machines, one of the pioneers of early computing, days in the 70s and the 80s, artificial intelligence enables computers and machines to mimic the perception, learning, problem solving, and decision-making capabilities of the human mind. So when we look at this definition, we can see that we are probably already using artificial intelligence in our day-to-day lives and are not noticing it. And this artificial intelligence has allowed many tasks to be faster, better, and more intelligent, but the question remains if they are human-like. So there is a debate on the topic that if AI is really intelligent or not, but we will not go there. But it has allowed many tasks to be faster, better, and more intelligent. Now if we look at the types of AI, we can consider AI as a superset. So what is a superset? In logic theory, we know that superset is a set that contains other subsets. So this AI encompasses everything that resembles intelligence. And in the traditional context of AI, we have machine learning and deep learning. So if we are trying to do a course on AI, we will find options about machine learning and deep learning. But in this presentation, we'll focus on the learning by machines and how it fits onto the other branches, such as supervised data, society, and the environment. So we are not going down the traditional route of machine learning and deep learning in our presentation. I have two sections. In the first section, I'm going to talk about geospatial data and intelligence. So how intelligence, this artificial intelligence, is being covered under geospatial data. We have we cannot see in the darkness. We need to get the data, the light, we need the light, we need to see the reflections, and we need to make informed decisions. So in GIS, we can do this using the best spatial data that is available. So it is important to use the best spatial data available because in cartography we have in cartography, we have data that dates back to a few centuries. So if we are using the best data, we can make more informed decisions. So this is a map, and this map shows the labeling of certain buildings in a locality. So in this time of COVID, we can have this map labeled as the COVID hotspot zones, COVID quarantine zones, and other sorts of data. So these tools are available at free of cost using various softwares such as GIS. And with these maps, we can have the associated tables, the graphs, and there we can see the data at a glimpse. And this is one of the approaches one can use when they are making informed decisions with regard to GIS using this artificial intelligence and other manual tools. When you work with spatial data and geospatial information systems, we can get the data from the Survey of India if you are working from India. So this Survey of India, as any of the geography resource persons in the audience can attest, that they have a lot of topo sheets, and this Survey of India topo sheets provide a very good overview of the geographical features of our country, and also it can be used in different research purposes. And from this spatial data, we can see. Let's see an example. In the right, we have this Gangetic West Bengal, and this shows the physiogeographical zones, and this includes degraded plateau fringe areas, upper Ganges Delta, lower Ganges Delta, and the coastal plain. And when we have this data beforehand, we can make our research process much easier. And many of the traditional parts of research, which we had to go to the live field to collect the data, we can get from the spatial data repository on the Survey of India. Now we need a structure to understand how this data is handled. The geospatial technologies is for data capture and management, spatial data infrastructure development, applications in biological and health sciences, which we will go in a bit, and research and development issues. Now we have a philosophical question. It is how to have wisdom. So wisdom is something more, something above this data, information, and knowledge. So when we have a wise person or a wise a system, a computer system you can call it, it is more than the aggregate of information, data, and knowledge. So it is something that is built atop this knowledge, information, and data. And this is one of the most valued piece of information we can have, valued piece of attribute we can have. And first all of these things we must understand is based on data. So this is not this is not a very soft science, but this is a hard science, and is based on data and facts. And this signals, and but it doesn't know anything. So data just gives you a series of numbers, an array of numbers, or other attributes, but it knows nothing. So we cannot make something out of data itself. So for that we need to create an information. When this data is given a context, it becomes information. This information is useful, organized, and structured. For example, if we see a map and we can have this latitudes and longitudes for every point and elevation at every point, but this data is not useful because it is without context. So to get the context, we have to convert it into information. We have to organize it and structure it, and thus it becomes the information. And when this information is given a meaning, such as the features, the topographical features point to a river or a delta or a hotspot for a disease, when this is given meaning, it becomes knowledge. This is contextual, synthesized, and it helps in learning. And when there is an insight given to a knowledge, this insight is very difficult to automate using artificial intelligence or other manual, other automatic tools in this day. In the future, we can have wisdom, perhaps we can have wisdom from automated systems, but in this day, it is not so easy. And this wisdom is understanding of all the problems and solutions, integrated and actionable. So we can do action based on wisdom. And from data, thus we can see that from data we can have knowledge, and then finally we can have this, after this information and knowledge, we can have wisdom. In the context of GIS, we have this human and artificial intelligence combined, and we can see a plethora of places where we can utilize this GIS. And for the early stage researchers and students, this can be very useful, because they can see how they can use GIS in their work, and often it can also be their play. And this we can have in, say, it can be, we can also have it outside of research in financial analytics, money saving, optimization, geophysics, and engineering management. This wisdom from GIS can be used in a lot of contexts. This can also be for survey vessels, and just in the recently we had this news that there was this cyclone near Mumbai, and these vessels were caught in the wind, and many people died. And this, we can have wisdom from GIS, and we can prevent this from happening. And although there is the scope of human attributed errors that happened in that particular case. So one of the pivotal tools that we have at our disposal is the global positioning system. So this is a satellite system. It is owned by the United States, and it derives navigational parameters like position and velocity by using radio signals transmitted from satellites. And there are a lot of these positioning systems. One is the GPS from the USA, also have GLONASS from Russia, GLONASS from the European, GLONASS from Russia, and Galileo from the European Space Agency, and also we have one from India. And this positioning system also helps in doing our research, because we can get the position, the altitude, and the change in those parameters through time very easily. Here you can see how these navigational satellites work. They are orbiting the Earth at specific heights, and they are a cluster of satellites, so that always some of them are in the view. And this provides a radio wave, radio signal, which can be sensed by the remote device which in our hands. We can also use it from our mobile phones, and this is how the navigation satellites work. And another part of GIS that helps us to gather the data is LIDAR, or light detection and ranging. So this uses pulse laser, and we have this ALSM, that is airborne laser swath mapping, and this helps in laser altimetry. I am telling all of this because in each of these particular devices and processes, there are a lot of research that is being done. For example, there are various types of lasers that are being developed for civilian and military uses, and they are also an exciting avenue of research, especially for those people who are doing their research in physics. And what is laser? Laser is light amplification by the stimulated emission of radiation. And this is a type of light that is not found in nature, and it's created by humans. So this is very interesting. And these are commonly generated in the UV, visible, and IR spectral range. So lasers can also be invisible. So if we are trying to map an area, we can also do it through invisible means, and this is sometimes done by the spy satellites, which can be in the news, because there are these wars and conflicts happening throughout this world in this time of pandemic. So these laser pulse generators use this specific nanometer diode pumped YAG lasers. So it is just showing how this laser mapping is being done. This is done by aeroplanes that fly at low altitude, and they can map the regions below the aircraft, and we can have the topographical data and also various other attributes such as the presence of water, presence of vegetation, and even the presence of life, such as animal life as well as plant life. This is also done for finding ecosystems for fishing, such as fishing, and also finding the changes in the regions over time. We'll come to that in a second. And this geospatial technology and digital ecosystem yields a lot of value to economy and society. So we have a lot of things here to discuss, and let's go by one. So in this geospatial data, we have GIS and spatial analytics, a part of this research. We have GNSS and positioning. We have observations from Earth. Many times what happens is that we obtain data from the atmosphere, but when we come to the Earth to observe them live, we see some differences, and this happens due to the specific limitations of such techniques, such as detection of oxygen, for example, is very difficult with lasers, and using the spectral analysis, because the wavelength that it emits is closer to many other molecules. So Earth observation is also a vital part of getting the data. And the drivers of this type of data includes the use of the cloud as we know it in the information system cloud, the online clouds. We have wireless and communication, Internet of Things, and robotics and automation also come under this geospatial technology and yielding value to environment and society. When we get the data, we need to facilitate it for further analysis. This includes use of big data. As we know, this is also a term that is thrown around a lot. But in this day and age, big data has enormous potential to be a game changer, and it is nowadays being used by private companies. But we should also be using it in research and public companies for our all benefit. And this includes ICT infrastructure. This includes standards and interoperability processes, which integrates all of this system integration. This also comes under business intelligence, and this business part is also very pertinent because we have this private and public exchanges and partnerships. We have this digital engineering and deep learning and artificial intelligence, and this can be used by the masses through enterprises, through social media, through mobile apps, and through web portals. And the users include citizens, businesses, and the government. And then we can find the geospatial value in world economy and society. All of these inputs are put into this analysis table, and then we have this intelligence. Acquisition, management, and then intelligence. So when we take a decision, we need these support systems, and this support system, decision support system, can be any computer system, hardware or software, designed to support decision makers interactively in thinking about and making decisions about relatively unstructured problems. These usually have three components in GIS: the user interface, the database, and the model. As we saw in the first topographical map, there is a database and there is a model. We are using this model and the user interface, and this is used by the user to interact with the software. But when we have intelligent GIS, we can have machine learning as a part of it, and through machine learning we can have a new database which is more structured and more informative, and we have the similar user interface to interact with this. This can be a part of intelligent GIS and is already being done in various softwares and cloud-based tools. For example, during hazards and natural disasters, we can have these databases and information in local, regional, and global scales, and we can have this risk assessed. So risk assessment is not something new. It has been there for many decades, if not centuries. But this risk assessment is getting better with the newer tools of artificial intelligence and improved databases. So risk assessment includes hazard maps, inventory, vulnerability, and location. And as we make better maps of this, we can have better outcomes in case of any natural disaster. For example, in this time of COVID, because we have certain models, we can assess the risk of this lockdown versus not lockdown versus the death, and we can make an decision, an informed decision. So this gets better when we have more information in our hands. There is always an element of risk, and we have to decide between what is acceptable and what is unacceptable risk. And after we do this kind of differentiation, we can have the anticipatory decisions, and we can do environmental protection or protection of lives and other digital support systems. So this is the infrastructure as we talked about. There is this distribution pipeline, and we have this output. And this, there are a lot of factors, there are a lot of valves inside, and we can get the output. The Spatial Data Infrastructure by the SDI Cookbook, it is a good book to learn from at a glimpse. So this, the technology, policies, and people necessary to promote sharing for geospatial data through all levels of government, private and non-profit sectors, and the academic community. So this is spatial data infrastructure and its goal. This includes the core data sets, as we talked, the geospatial data, policy, metadata, that is data associated with the core data, such as latitude, longitude is the core data set, and we can have other metadata such as this belongs to this country, this belongs to this subdivision, such as those. We have these clearing houses. This clears the data and makes it more accessible because it gets rid of the useless data, such as oceans which are not being considered for a specific purpose. And then we have standards, like in maps, we also have standards in spatial data infrastructure. We have this organizational framework, resource partnership. We have this machine learning, artificial intelligence, and finally it comes to the end user to use all of these. So these are all this part of the spatial data infrastructure, and it is quite a juggernaut, and we can do a lot of things in every part of the process. So it's not that if we are going to do with some work with GIS, we have to use just maps and label parts. It's not just that. We have a lot of other things to do and useful things to do. So here are some of the topics that we can do research on, and research is being currently done on. One of these includes accuracy standards for digital geospatial data. We see in our mobile phones we have this GPS, but it has an error of around 10 meters. If you're using a better capture device, we can have a reduced accuracy. We can have an increased accuracy. So these accuracy standards is an useful avenue of research. We have the spectral signature repository. This gets spectral analysis of objects, and we can get the spectral signatures such as of oxygen and ozone. And this is also being done in other planets, in astrobiological realms, such as in Mars and some moons of Titan and moons of Saturn and moons of Jupiter. It also involves integration of data from multiple geospatial sources. This is also an avenue of research. We can have high definition maps, imaging, and videography as a part of research. And so there are all of these kinds of work being done. And in my personal research, I have used a small part of this, but we can see that there are many options available for people who are interested in this. In geospatial data management technologies, we have this AI and deep learning, and we also have data processing technologies, and this includes big data analysis, geovisualization through virtual reality modeling. This happens all the time, such as in Google Street View. We have this virtual reality modeling of spaces. We also have cloud computing that does the heavy work, and we can have useful information in cheap laptop through cloud computing. But now let's focus on applications in biology, because this is the applications I have used in my work. So I came to know about these GIS tools first from the land use dynamics, and they are being used there. So it shows the change in forest cover over time. So this was done previously using hand-drawn maps, and they were lot less accurate, and the changes were very. It took a lot of time to the changes to reflect, and therefore the research was less precise. And now we can see, using various tools, we can have this maps digitalized, the old maps, and we can create new maps, and we can see that how this change in forest cover occurs. And when we see this change in forest cover occurring, we can make informed decisions about what types of research we can do there. So when we have this change in forest cover, we can know that this type of research can be done there. So this was the use of GIS in the showing the temporal change in forest cover. This includes such as these tables, and it shows the change in the land cover and use with this element of error, which is also very important if you are going to do statistics. And thus we can see in this place of this state of India, I think it's Karnataka, we can see that there has been lots of loss in the cover of forests. So forest fragmentation happens from intact forests. It's called perforation. Then we have fragmentation. The forest is being broken up into many smaller parts. Then you have dissection and shrinkage of forest cover. And here we see a type of graph, and it shows how this forest cover reduction is being computed. So when we know this type of computation, we can know how the computer does this. And using these powers of computers, we can make this process automatic, and we can save a lot of time. But still, we need to know how it is being done. So computation of forest pixels, and which are not forest pixels, are done in a grid of pixels from a map. And we can see the in this map, 15 of the 25 pixels are forested. So PF is a term we are using for calculation is 0.6. And when we have sorry, and we can make this table when PF is equal to 1, it is a part of the deep forest. When PF is less than 0.4, we can see that it is a small wooded lot with a built-up region, and when it is between these some values, we can see that it is a perforated type of forest. So these things are being automated using geospatial software, and this saves us a lot of time, and we can have a lot of data for big regions such as whole states. So in this map of Bolivia, we can see this type of labeling on the types of land masses and the type of people living there, and this socio-economical aspect is also something I am personally interested in and I have worked on. So these are methods to map the eco-sensitive regions. And in statistics, we have this calculation of weighted averages, and this is an example of how these weighted averages are being done. So let's say if we have an exam, and from quizzes we get 82 out of 100, exam itself we get 90 out of 100. There is a weighting factor which we decide, and we multiply these two terms to find out the weighted average and weighted average of each individual items. So this is a part of analysis which we always do in other types of research, such as from ecology, hydrology, geoclimatic, and everywhere we can do this type of weighted averages. So this is just an example of how these mathematical things are being done using computer or automated processes. So this type of information can be correlated with protected zones, such as in maps in West Bengal. We can do botanical studies, and we can also do studies with insects, such as species richness and dendrograms. And we can do in the field collections and find out how much of our data is being useful. This is one of the portals, Geosymbio. It's a hybrid web application and global geospatial bioinformatics and ecoinformatics for host symbiosis based on a genetic sequence. This is one example of website where you can have this type of synthesis between biology, maps, and even genetics. So now we come to the geospatial application in health. Geospatial application in public health in the Indian context is used for some extent for locational planning, but not in epidemiological studies and disease surveillance. So this was the thing before the COVID hit. Now we think we have a somewhat better, but still it is lacking. So application of geospatial technology in biology and health involves methods for disease and risk mapping, methods of spatial patterns of diseases, hotspot detection of diseases, spatial epidemiological models. As you can see now, we have one model from one of the IITs about the COVID spread and when we will have the peaks and when this will this will go away. These types of things are being done. In one of the Sustainable Development Goals of the UN, there was this thing of national spatial data infrastructure. So a national spatial data infrastructure was to be made, and this was one of the Sustainable Development Goals. Now we come to my section of BSM coding and surveys for public health. What I did here. So at first we need to go through some of the examples of public health efforts using software. In the international context, we have from the NHS UK a comprehensive, universal and free at the point of delivery healthcare. And this, the software side of this includes NHS Choices. This provides online consultation and services. And in India, we have this National Health Portal. I am not going to comment how good or bad it is, but it has been recently launched in 2017, and it combines a sort of different services and related to online healthcare. It is in the nascent stage, and everything has a nascent stage, so we can be very harsh here. So this emergency research and solutions was our first try in software development in this context. So in India, we have the death rate from accidents is the highest in the world. It is the highest, and it's a very bad statistic, but it is the highest in the world. And this requires pre-hospital awareness. So what is pre-hospital awareness? It is the awareness of what to do before the patient is transferred to the hospital after an accident. A Cambridge study was done, and it stated the lack of formal EMS, that is emergency medical services, in Mumbai, which is the most bustling city of the country. And the study also says that the average victim of an accident is a young man in his late 20s and from a lower socioeconomic class. So this grim statistics shows the need of pre-hospital awareness, which can save a lot of life, and software technologies can play a pivotal role in imparting the same. And why is it so? It is because we have the speed advantage, because you can use the software very, very quickly, and everyone has a phone these days. 76% to 80%, I think, are using a smartphone these days in India. And there are some caveats to the study. We will not go there. And this also has the cost advantage because the applications can be provided to free as compared to, say, books or other leaflets which need some money and they are locationally limited. They have the advantage of accuracy because we can have up-to-date information about the hospital facilities, the healthcare facilities in the application, and the scalability advantage is also there. So this software can really be scaled very fast and very fluidly, such as we see for various softwares we are using, such as Uber, this Google Meet and such. They have a lot of monetary resources, that's true, but still they have a lot of scalability. So here is a problem for some of the younger members here. So a car hits a passenger, a bicyclist, and the question is how to help him. Which one of these choices will you choose? So there is one choice: carry the victim to the nearest healthcare, perhaps in a motorcycle. So let the victim drink water and try to talk with him. and the third choice is just ask someone to call an ambulance, and the fourth choice is take a picture of that. And many of, not many, but some people, what they do is they just take a picture. There is an accident. We are seeing it in social media. This is a bad situation. But the correct answer here is actually none of these. So why? Let's look at this prototype app we had developed a few years ago. So emergency road accidents. So it is imperative to not let the patient move unless it is absolutely necessary. This is because in case of neck injuries, a detached spinal cord can result. So when there is an accident, we should not move the patient unless it is absolutely necessary. So if he is in the middle of the road, we should move him. But if he is lying in the side of the road, we shouldn't move him unless it is absolutely necessary. Instead, we should check to maintain the A, B, and C. So this A is airway, B is breathing, and C is circulation. So the people who have this medical knowledge or knowledge about first aid, they probably know it. But this ABC needs to be attended first, and not something else such as moving the patient or moving him in a motorcycle. In our software, what we did was trying to prototype this first trauma care localization. So it takes the location of the current location in the device, and it shows the trauma care which is closest to that place. We have the verified information that are partially verified. We had this contact information. We have the support of local languages. This is also a thing, because most of the software that we use today are usually in one language, that is English. So local language is one of these important things. And the methodology in this prototype small software was short-term care but long-term teaching. So this application had the capabilities to take your address, and through natural address processing can show a list of accident centers nearby. So this was one prototype. It needed improvement, but we just tried to see how it can work. So we had some special features for targeting, and this had also some interactive games and quizzes for keeping the app installed and for being used as a teaching tool. And the dependencies were a minimum, and analytics were also there. So this is a list of the first software which we developed, and then we developed BSM. So what is BSM? BSM is a blissful script manager. It's just a name, and this was our solution, and we are currently working on this solution in a bigger scale. So this was the paper, Introduction of a New Programming Tool, BSM, for vector biology and public health, and measuring its likability using a survey. So this BSM is a software, and we can make other software using this BSM, and this has the support of encryption and the support of modules which you can utilize inside the BSM. And this is the brief workflow. You can see that there is only 7 steps in making a software and also locking the software for use by the end user. And this is one of the software that we develop inside BSM. This shows types of mosquitoes. It collects what kind of mosquitoes are available there by a text box. It can also show the maps of the regions, and we can send the collected data through online mail services all in one go in a straight workflow. And this application we developed, one of the modules, this can be facilitated by using only 22 lines of code. So using the counting the space and blank lines, this is 22, but in usually it is around 13 to 15 lines. So only by this 22 lines of code we can make an app such as this using BSM and its modules, and therefore it is an advantage over the existing solutions. So we tried to measure its likability using an USC questionnaire, and many of the survey participants told us that it has helped them to become more effective, more productive, It is simple to use, and it requires the fewest steps to accomplish what I want to do with it. And many of them also said they would recommend it to a friend. And it is some of them said it was a little bit difficult to use, but with a new software, I think we can expect a bit of that. And so in the first step, we worked on affordable hardware and approachable software in ICT for development. And then in the second phase of our work, we tried to maximally leverage the contemporary technologies. We made an Android app because these Android phones are being used at high levels, such as 42%, and we also used HTML5 because it is platform agnostic and it can be used in any platforms. We did a survey work and GIS-based work in a rural area of Purbo Bardhaman and demarcated into 3 zones and carried out surveys, and we found out the capacity for introduction of technological tools as well as knowledge about vector-borne diseases. And we did a comparative study with Bangladesh. These were the Bangladeshi students who were participating in the research process, and we found how to get deeper and hands-on with the problem at hand, that is inclusive development with focus on mosquito-borne diseases. This is a public health topic of a lot of discussion, and this Bangladesh was chosen for its socioeconomic comparison. And various subjective and objective parameters were taken using surveys, using software, and our BSM tools. So this coding will continue to be a main focus in this research work, and we planned a multi-purpose bottom-up integrated development environment for vector-borne disease eradication, larger public health and related skill uptake. So in the first slide, we talked about bottom-up development. So what is bottom-up development? So in this day, the software that we are using are mostly top-down, such as these Google softwares, the Android softwares, the, let's say anything, Apple, Microsoft Office. These are all top-down things, and many of the public health initiatives that are being done are top-down. So they plan it in the center or they plan it in the state, and they populate from top to bottom. But can there be a way for bottom-up integrated, bottom-up development? So there can be a way, but it is difficult. So we are trying to go down this route and make it more easy by making a bottom-up integrated development environment for software, and such that it can be used for vector-borne disease eradication, that is mosquitoes, and larger public health and skill uptake. And we found that a large percentage of middle and lower socioeconomic classes that we don't really see in a lot of news, that they are not versed in English. So English is a subject that is difficult for them. So if they do not know English, how can they be good coders or good programmers or good health workers or public health workers who utilize this software? So regional language focus will be paramount. And we had to make code creation and executions have to be made simple so that more people can participate in it. So we don't want 5% of people participating in this. So we want more person to be in this integrated development environment, and thus we had to make code creation and execution simple, and thus we see this only 12 lines of code for this application, which would have used at least say 50 to 70 lines in other computing standards. So we did our study and we found out the results here. So in our village area, we found there are 3 different zones that we demarcated. One of the is the old fringe area of the village. Another one is the new fringe, which is near the highways and has many migrant and new settlers. And the third area is the core area, where most of the affluent and old people, older residents live. And in this work, we utilized GIS, we utilized application that we made, and we also did surveys using manual surveys. So this is a custom map which we used in our work, and we can see there are these three types of places which are highlighted in this map. This is just one of the various maps we have developed here, and many of these processes can be automated, and anyone working in this type of research can use this automated forms of maps. And this is the regions, and we found out that almost 83% of the people in the newer fringes are using a smartphone. 50% have used a computer at some point, but only 8% have used programming. They know programming. But on the other hand, we have 82% having menaced by mosquitoes, so there is a problem of mosquitoes there. Although they are using the traditional methods of mosquito eradication, such as using nets, and in this optimal eradication, we try to measure how much they are satisfied with the eradication drives that are being conducted there, and we also try to gauge their personal protection levels on how they are using personal protection, such as mosquito repellents and oils, and we did a survey there. And one of the software we provided to them who had access to a phone, in the villages nowadays many people have phone, that is a welcome relief, and we've made an app called Mosha Gamon. It is in Bengali and also has English language support. It hosts a wealth of information about mosquito-borne diseases, and this was done using data from various reputed websites and also from the help of our professors in our university. And this skyrocketing rate of mobile internet penetration in India was one of the drivers of making this application of Mosha Gamon. And on the other hand, from Bangladesh, we can see there is another map here. This was another custom map, and we did this work in Bangladesh, and we found that when we go to a new place and we have to introduce a new concept, there needs to be another focus, another hinge on which this new methodology can be worked upon. So we chose Ishwar Chandra Vidyasagar and highlighted him there, along with Begum Rokia, who is a Bangladeshi person of repute. And this, from this Ishwar Chandra Vidyasagar, we can get the concept of simplicity and a leader to look up in the technological age. So when we go to all these sections of the society, we have to connect with them through various means. So if we are using this new software, we also have to link it to other ways that have been used in the past. So Vidyasagar worked when malaria plagued the town of Bardwan, and using the legacy of Vidyasagar inside the app, we can make other people interested in the app and the subsequent processes. We also found in Bangladesh that there is a deep need of this local language, and this inspired us to create Bongo Jantra, a module where we can program in Bengali, and this is partially based on BSM. And this we also wrote a book, Bongo Jantra Software Suite. It is easy programming in Bengali, and this book is in a dual language edition. So people who are using who read English can also use it, and people who use Bengali as their main language, they can also read it. This is our software. You can see this is very stark and modern looking, and this is a part of BSM, and this is an integrated developing environment where you can develop software in Bengali and also as module support. So when we shared these modules with these people in Bangladesh, we also took other surveys using manual means, and we found out that many of them do use smartphones, do use computers, but using programming was much lower, and there we had the scope of improvement. This is the values that 60% using 60% reported using a smartphone on their own, and 17% only used a computer in the household. So this was in Bangladesh, and in India the situation was somewhat better. We also found out that 26% of the volunteers there, they were of school age. They know some kind of programming, although their grasp of the programming wasn't that great, but still it is a very much a growing nation, and programming can be a very valuable tool of this research work using vector biology and public health for the betterment in this regard. So we also found out analysis of word usage using visualization. This is how our software works, and we found out how they describe where mosquitoes lay eggs. We also found out what kind of repellents to use. This is we are just showing here how this survey was done, and you can see the students there, and they were very eager, but we do need more of them to make our research successful one. This is the Mosquito app which I developed about a few years ago, and these are the screenshots. And we can see that there is also a small mini game inside there, so that people who install it keeps it and uses this information for providing data to authorities and other reputed person for further research and eradication. In BSM, we had some nitty-gritties, such as it uses a layered approach, so there are multiple layers. So one person working in one layer need not know the other layers. So this is useful for making novices and experts use the same software. There is also access control integrated in BSM. We can use key files. Key files are files which are used as key to encrypt or decrypt software. The audience members who are in this computing field can relate more easily. It also supports runtime encryption, runtime decryption, and simplified user access. So non-experts can also code using BSM, and this coding can be for beginners. This coding can be done for social development. So the final word I want to say in this very long lecture I have been giving today. So relating to environment and development, my take on BSM's possible role. So I want to say that environmental awareness can be realized in practice to an appreciable extent only when there has been a considerable HDI development. So when there is no HDI development, we cannot have environmental awareness to an appreciable extent. So the prerequisite does not guarantee an adequate amount of awareness. So we can have considerable HDI development, but we can still not have environmental awareness. But we need HDI development for getting the environmental awareness. It won't happen automatically. That's what I'm saying. So jumpstarting this HDI machine can be effected by putting more people under the umbrella of skill development. So we have skilled and unskilled development, but in the coming years, we see this gradual phasing out of unskilled development, because we have these computers, we have machines, we have these corporates and whatnot, and this HDI machine can be jump started only by putting more people under skill development. And this skill development, such as in software development and related roles, BSM can possibly play a tiny role here. And this is an area of active research, and I am doing some. I'm sending some papers to publications. So there is a little bit of more work to be done here, but I think it can possibly play a tiny role in it. There are a few books and software published in this regard. One of them is Bongo Jantru, is a book, it's a dual language edition. We also had made a book last year, Progressive Web Apps for Social Development. This book was about making web apps for social development and this public health part. And we had this dual language edition of Bongo Jantru guide, which we are now providing free in our website. And we also made Mosquito, as we said, an app for mosquito control. And we had made a B script, which is an older niche interface for developing apps. So these are some of the books and resources, and some of this will be uploaded free of cost after we publish our last paper. And that's it for now. Thank you very much for staying with me for so long and listening to my lecture.
Thank you, Vishnu, for your very good presentation. This is a new type of presentation in this platform. Our participants are from different area of research and knowledge. So I think this lecture is useful for some research scholars as well as knowledge hunting participants. From the chat box, many appreciating comments depict that they enjoy the webinar. Thank you again, Vishnu. So as usual, we are at the last stage of this webinar, and now this is question answer session. Participants, if you need any answer and have any query, please write it in the chat box.
Yes, that will be great.
No question in the chat box. No question in the chat box, Vishnu.
I want to send a link about my software in the chat box. I think it works.
Yes, obviously. It is useful.
This is the link I sent is about Bongo Jantro, and this is in a beta phase. It is not final piece of software, but you can try it, and we can discuss that in the comment box there about any problems or bugs, or if you have suggestions for improvement or getting a part of this research. So thank you very much.
So no question as in, so I am asking Dr. Devabroto Das, who is our secretary of this webinar committee. Please, sir, you conclude the session.
Thank you, Vishnu, your nice deliberation, BSM coding and everything that is related to research is very opportunistic. So one can take this opportunity to develop his or her research in this field. Actually, Vishnu, once when I was coordinator of the research in medicinal plant conservation network in North Bengal, particularly Boksa Tiger Reserve and Lataguri Forest, that time Vishnu was with us.
Yes, sir. And it was very fun.
Vishnu's mother actually, Nirupama Goswami, Dr. Nirupama Goswami was the head of the department of Baron Raj College, Bardwan, and this is called Bardhaman in West Bengal. All we visited the forest and actually developed research on different aspects, particularly on the medicinal plants, ethnobotany, aromatic plants, and so on. And after that, a few gap in between to that is 2014 to 2021, Vishnu again met with us and delivered the lecture here in this platform. Nice deliberation, nice presentation, Vishnu. Again, I'm telling to develop. And lastly, I'm saying that Vishnu published many books on software and this including and subject related networking, etc., etc. So, thank you all our beloved participants who enjoyed this seminar well in this platform. One announcement is here that Mrs. Priyanjana Ghosh, Senior Lecturer and Course Architect of Life Science, Biotechnica Info Labs Private Limited. Priyanjana will deliver lecture on 29th May 2021. Our topic is impact of COVID-19 on nature and biodiversity. So, participants, please go to the WhatsApp group and Telegram group. We post today the link for registration in Endev 9, Endev that is Environment and Development, and take number 9. And similarly, in June, 5th June, we will cover another lecture at Endev 10. And Endev 10 will be delivered by our professors from Maharashtra State. Madam will deliver lecture. Madam from Abba Sahib Garwara College, Karvi Road, Pune. First topic is studies on allelopathic interaction of some invasive weeds of Dex plateau. Dr. Ghayal Nivedita A. from Department of Botany, Abasai College, Kardi Road, Pune will deliver picture on 5th June. Obviously, register for those lectures. After that, we will conclude our that is Endev series 1 lecture, and we will back to the series 2 lecture. And first lecture is voting on 12th June 2021, but second lecture is ready for 19th June 2021. Vinutha Bhatta from Karnataka will deliver lecture. Madam is one participant since 2020. That is all lectures attended under Biodiversity Series 1 and Endev 1, and will deliver lecture under Biodiversity Series 2, and ma'am's topics particularly on honey, social insect honey. So participants, please stay with us. On 5th June, we will complete our Endev series 1, and after we will go to our next series, that is Biodiversity Series 2. So today's program is over here. So conclude here, that is go to the next webinar for Endev. So today I will post the link for registration. Go to the WhatsApp and Telegram group again. Do not leave the WhatsApp group and Telegram group. Thanks again. Thanks all participants and our resource person. Good night.